Hello, I am Peter, and I will be guiding you through this module on different mathematical tools regularly used in financial analysis. This time, let's talk a little about kurtosis, a statistical measure that describes the shape of the data distribution, or more specifically, the height and width of the tails of the distribution compared to a normal distribution. While skewness focuses on the symmetry of the distribution, kurtosis is concerned with the peakedness or tailedness of the distribution. Leptokurtic distributions, which have a kurtosis greater than 3, had heavier tails and a taller, narrower peak than a normal distribution. This indicates that there are more extreme values, both high and low, in the distribution. Mesokurtic distributions have a kurtosis equal to 3, and thus a shape similar to a normal distribution, with moderately sized tails and peaks. An example of a mesokurtic distribution is the standard normal distribution. Platykurtic distributions, which have a kurtosis less than 3, have lighter tails and a lower, wider peak than a normal distribution. This indicates that the values are more spread out and there are fewer extreme values. In this video, I want to focus on the steps necessary to calculate this important measure. Let's get started. We will perform the calculation step by step using Excel. The first step is to calculate the average return. This average return is the result of adding all the monthly returns and dividing by the number of months of data. We can also interpret it as the return we predict when looking forward. After calculating it, this return is 2.67% for TTI. Once you have the average return for TTI, you can now calculate the variance and the standard deviation of its returns. Remember that we performed these calculations step by step in one of the previous videos on standard deviation. Just to refresh your memory, we need to calculate the deviation of the return for each month from the average return. These deviations must then each be squared. Finally, remember that the average of these squared deviations is the variance, and the square root of the variance is the standard deviation. You can verify that your answers are correct using the Excel commands var.p and stdev.p. As the third step to calculate kurtosis, we need to raise the deviation of each return from the average return to the fourth power for each month. Then we sum these deviations raised to the fourth power. In this case, this sum equals 0.00000021. This is the numerator of our fraction to calculate kurtosis. The fourth step is to determine the denominator of the kurtosis formula. This is simple. You just need to raise the standard deviation to the fourth power and then multiply it by the number of observations. In this case, the result is 0.000076%. Finally, we just need to divide the sum of the deviations raised to the fourth power, which is 0.00000021, by the denominator of 0.000076%. The result is 2.818, which is the kurtosis. In this case, we cannot verify the kurtosis calculation using Excel. The kurt command in Excel calculates excess kurtosis when evaluating a sample of the data. In these calculations, however, we have calculated the kurtosis itself, assuming we are evaluating the population and not a sample. Thank you for your attention and for the great work you've been doing. Let's stay in touch.